The next thing we're going to look at in this unit is calculating average atomic mass using percent abundance. So we already know that each element has different isotopes that have different atomic masses. So now we're going to take a look at what does that mean. Now we have what we call relative abundance, and that is the naturally occurring mixture of isotopes for an element expressed as percentages. So for all of the boron that exists, okay, we have boron 11 and we have boron 10. Okay, so all of the boron you can find is either boron 11 or boron 10. Now, relative abundance tells us that of all the boron that there is, 80.22% is boron 11 and 19.78% is boron 10. Now, depending on the element, we can have 2 isotopes, we could have 10 isotopes. But the main thing is our percentages are always going to add up to 100. Now, this says, so if atoms of the same element have different masses, what is the mass on the periodic table? How do I decide, looking at my periodic table, that boron has a mass of 10.81? Where did that number come from? Now, a lot of people would automatically look at that and say, well, it's an average. Well, it is, but 11 and 10, the average of those two numbers is 10.5, not 10.8. So what we do is we take into consideration that 80% of the boron is boron 11 and 20% is boron 10. So the mass on the periodic table is what we call a weighted average. So when we're figuring out our weighted average, what we do is we take the mass of isotope 1 times the percent of iso 1 plus the mass of iso 2 times the percent iso 2, and so on and so forth. If I had 10 isotopes, we would continue. We would do the mass of isotope 3 plus the percent of isotope 3, and so on and so forth. Now, the tricky part here is the percents, okay? So some people like to turn these percents into decimals right off the bat. Some people like the percent button on their calculator. For others, I've found that this method is much easier. You just do this math first, and then you're going to divide your answer by 100. Now, my answer should always fall somewhere between the masses of my isotopes. So let's do this one out right now. I'm going to take the mass of isotope 1, so I have 11, times the percent plus mass of isotope 2 times my 19.78% and divide this whole thing by 100. So when I do this out, using my handy dandy phone calculator, I have 11 times 80.22 plus 10 times 19.78, and then I'm going to divide that number by 100. So in the end, I end up with an average mass of 10.8, 0, 2, 2, etc. Now, when I look at my periodic table, my answer should always be really close to the mass on there. So here it says 10.81. 10.80 is pretty close. Okay? 10.80 comes between these two numbers. And it's closer to 11, which makes sense because 80% is boron 11, whereas only 20% is boron 10. So I want you to take some time now and work through the average atomic mass assignment. Want me to